This is question 3, 2011 Higher Paper 2. To do with sequences, this one, let's write down a sequence. Term U0, term U1, term U2, term U3, and so on. Eventually we'll come to term UN, followed by term UN plus 1. This rule here tells us that the term after term UN you will get by multiplying term UN by minus a half. This term can be obtained from this one by multiplying by negative 1/2. Now, n can be anything. It can be 0, in which case this would be 1. So U0 followed by U1. That's down here. So this general rule tells us that to get, in particular, from U0 to U1, multiply by negative 1/2. N could be 1, in which case this would be 2. So U1 followed by U2, that's here, and the rule still applies. It's a relationship between the terms of the sequence that recurs all the way along the sequence. It's a recurrence relation. So there's the setup. Information that we know is that U0 is minus 16. And we're asked to find U1 and U2. U1 then will be obtained from U0 by multiplying by negative 1/2. So U1 is negative 1/2 times 16. So negative times positive is negative. 1/2 of 16 is 8. So this term is negative 8. U2 can be obtained from U1 by multiplying by negative 1/2. So U2 will equal negative 1/2 times negative 8. Negative times negative is positive. 1/2 of 8, 4. So that's positive 4. And so it goes on. So these are the first 3 terms of the sequence. U0, U1, and U2. Minus 16, minus 8, and 4. Moving on to part B of the question. Same sort of setup, but this time a different sequence. So let's do the same as we did before. You'll notice that the relationship this time involves V's and not U's. So we're starting with a sequence V1, V2. Remember, V1 is what they start with. In the previous one it was U0. V2, V3, V4, and so on. Eventually we'll come to Vn, followed by the term Vn plus 1. So information we're given this time. The rule tells us that to get the term following Vn, that's Vn plus 1, we multiply Vn by P and then add Q. So to go from here to here, multiply by P, add Q. In that order. Multiplying by P, then add Q. Of course, we know that because n can be anything you like, that implies that that rule works all the way along the sequence. So multiply by P, add Q. To get from there to there, multiply by P, add Q. And that rule works all the way along the sequence. So let's tie this up with what we know. V1 is 4. This term, the first term in the sequence, we're told is 4. So to get V2, we take v1, multiply it by p, and add q. So to find v2, we take p times v1 plus q. Now, we know v2 is 5. So to get this 5, we had to multiply this 4 by p and add q. So 5 is p times 4 plus q. Or as we'd normally write it, 4p plus q is equal to 5. Just swapping the order around, replacing this by 4p in the normal way. And you'll see why I've turned it round that way in a minute. Also v3, the term after v2, is obtained from v2. This term is obtained from this by multiplying by p and adding q. So p times v2 plus q, and you'll end up at v3. Now we know numbers here. 4, 5, 7 is v3. So we know that this 7, v3, we will get from this 5 by multiplying it by p and adding q. So another way of writing this, 5p plus q is equal to 7. Now you'll see why I've written it the other way around. You'll maybe recognise this as simultaneous equations. When these two act together, they both have to be true. Let's just subtract the top equation from this bottom equation. So 4p away from 5p gives me p. Q taken away from q gives me 0. And that'll equal 5 taken away from 7 is 2. We've now discovered that p equals 2. And good time-honoured fashion, let's put the value of p back into one of these to find the value of q. So we would let p equal 2 in, and I'm choosing the simplest one, the top one, numbers are slightly smaller, in 4p plus q equals 5. What does that mean? It means that instead of 4 times p, we've got 4 times 2 plus the q equals 5. So we've got 8 plus q equals 5. So q, we take 8 from both sides, q must be 5 minus 8. So therefore q equals 5 minus 8, which is minus 3. So there's our two values. P is 2 and q is negative 3. So last part of this question, part C, involves looking at both the sequences that we've already discovered. Now, part A sequence had a rule. The term following un you get by multiplying by -1/2, and in the second part B, the term following vn is obtained by multiplying by p and adding q, and we discovered that p was equal to 2 and q was -3, so adding -3 are same as subtracting 3. So there's our two sequences, part A sequence and part B sequence, and it involves limits. Now, limits of a sequence, when you work out all the values of that sequence, sometimes they get closer and closer to a fixed value. And that only happens when this multiplier, the number that's multiplying here, this multiplier, nothing to do with this term, but the multiplier, the number that's multiplying the previous term, when it lies between -1 and 1, there will be a limit. So a limit exists. A limit exists when the multiplier lies between -1 and 1. So that would imply that this sequence, the one in part A, has a limit. And let's suppose the limit for sequence U0, U1, U2 is L. So eventually, this is by way of explanation, eventually this sequence will become nothing but a row of the same number. And remember, the process that we got to get from one to the other involves multiplying by -1/2. So whatever that limit is, it will be unchanged when you multiply it by -1/2. That's the rule of the sequence, and we want to put a number in here, multiply it by -1/2, and it produces exactly the same number. That's what the limit means. So we've ended up with this little equation to solve, and let's add 1/2 L to both sides, in which case the right hand side here would become 1.5 lots of L, and this would become 0. So 1.5 times a number gives me 0. There is only one choice for that. The number must be 0. If you're confused about what I did there, why not multiply both sides by 2? Let me try that, and it'll be a bit clearer. 2L. When you multiply -1/2 by 2, you get -1, and -1 times L just gives you -L. So maybe that's a bit easier without the fractions. We add L to both sides there and would get 3L equals 0, in which case L equals 0. So either way, the limit is 0. Now, the reason that the other sequence doesn't have a limit, that's this one, the multiplier is 2. So for, what would we write, for Vn plus 1 equals twice Vn minus 3, no limit exists. It's important you state these things. No limit exists since the multiplier is 2 and does not lie between -1 and 1. So there's the reason that the sequence generated by this recurrence relation has no limit, and the sequence that's generated by this recurrence relation does, because -1/2 lies between -1 and 1.